Yeah.
Hello everyone. Welcome to Software Testing Expert Talk series. Today we have a guest who is a software test consultant having close to 6 years of experience in the IT industry so far. He carries proficient knowledge in test automation and various tools related to it. Plus, he is the founder of Testing Mini Bytes, a YouTube channel where he posts various helpful stuff related to test automation for test automation aspirants. Our guest for today's STET session is Amuthan Sakthivel. Hi Amuthan, welcome to our show.
Hi Ajay, how are you? Hi guys.
I'm doing good. Guys, today Amuthan is going to give a session on Java 8 and design patterns for automation testers. Let's hear from him directly. Over to you, Amuthan.
Thank you Ajay. Hi guys, I hope you're all doing fine, and we'll get started, right? So before starting this session, I want to tell few things before we get started. Okay. So we have been coding, right, a lot of Java code so far, right? So all this time we were using imperative style of programming. We have never used a functional style, or we never tried to leverage the functional programming in Java, right? Other programming languages are already using them more frequently, but in Java and in test automation we don't have some good content in YouTube. So what I thought, okay, why we cannot have a good playlist where people can start learning about functional programming and then try to use that in their code, right? So what I'm going to do is I'm going to pick some use cases in test automation. I'm going to do the imperative style of programming, then I'll try to convert them into functional style and see how less code we can write with functional style, right? So let's get started, guys. So let's get started with our first use case. So first use case is very simple, guys. So I'm going to open an Amazon link, and I'm trying to fetch all the links from the Amazon homepage. I'm going to ignore the second use cases. I'm going to ignore if there is duplicate strings, okay? And I'm also going to ignore empty strings from them. I'm going to sort them in an alphabetical order, and then I need to print only the text that is starting with A and B. This is a very simple use case, right? So you log into our website, fetch all the links, get the text from it, remove the duplicates, remove if there is an empty string, sort them in an alphabetical order, and filter out only the strings that starting with A and B, right? Very simple use case. So let's try to do that, right? First, let us do that old way, right? The conventional way of doing things. Okay. So let's name it as a print using old way. Okay.
All right.
Let me pass elements here. Okay. So let's create a method. Okay. Let's create a method that's gonna do all this operation and print the required output. Okay. That's as simple as that. So how we will do that? So you have a list of elements, you need to get the text from them. So what we have to do, there is no other way apart from running a for each loop, right? So or for loop. So what I'm going to do, I'm going to iterate it. Okay, I'm elements, and it's elements. I'm iterating the elements list, and I'm going to fetch each of the string, right? So let me create a temp variable. So elements dot get text, right? This is a simple way. So first I'm going to apply some conditions, because we have some conditions. So we want to remove the empty string, we want to remove the duplicates, we want to sort it in alphabetical order, but we're going to do the first condition, that is we want to do the remove the empty strings from there. So what I can do, I can tell temp dot length. If the temp dot length is only greater than 0, I want to add to the maybe I want to also remove the duplicates, right? So I can just directly store it in a set, right? So set string, I'll create a new hash set for now, and let me import these classes. Okay, now what I'm going to do, I'm going to add to this particular set collection, right? Whatever the temp that I'm getting. So this will also remove the duplicates, as well as we are also applying this particular condition. Okay. At the end of the day, we now have a set. And then what we have to sort them in an alphabetical order. So maybe I can leverage collection.start, but for that I need to convert the set into list, right? So what I can do, basically I can create a list string Okay, see guys, we are creating a lot of new collections every time, so this occupies space, right? So this is a bad thing. I'll try to optimize with the streams later, right? Well, let me create it as new array list. Okay, and now I'm going to pass whatever the set we have. So what it does, we have a set. I'm just passing to the constructor. So what it happens, it now becomes list. So what I can do, I can use collections dot sort. Okay, I can use a basic sort of this particular list. Okay, once I sort them, I need to only print the text that is starting with A and B. So what I can do, I can run a for loop again, and this time I'm iterating list. So this is having string. We introduce another variable and list. So only if the temp dot starts with, if it starts with A or starts with B. Okay, starts with B. So this is the condition. If only it's starting with A and B, I want to do a print of that particular temporal string. Right. So see how many lines of we are writing, right? So Ajay, you can see, right, we are writing a lot of verbose code here. So there is a lot of chances that we can make a mistake here. Let's try to check whether it is working fine before we try to optimize this piece of code. Okay, this is showing some error from another class, builder design pattern test. Okay, let's remove it. So now it should launch the Amazon site, and it should print only the text, okay, that is having A and B. Okay, though we are doing a lot of operations, but all we are interested is to see the final text. Okay, if you notice, we are only getting A and B, right? So this is what we want, but we have written a lot of code. Now let's try to optimize this with a simple Java 8 way. So let's print using Java 8 way. Okay, so let's again pass the same thing, and let me also create a method for this. Now I have a list of web elements. What I want to do, I want to convert them into stream. There is a stream method that converts this web elements into a stream of elements. Okay, you can imagine like you have a stream of water flowing into you, right? So you can do a lot of operation with that. In the old way, what is happening, we are trying to fetch all the values. Okay, so we are getting one by one values, but here in stream, all these values will flow to you. You can do whatever the operation you want. So let's also I want to convert, or I want to get the text from each of these web elements. There is a method called as map. Okay, and what I'm doing in this web element, okay, get the text out of it. That's it. It'll fetch all the text from the web elements. Now what I want to do, I want to remove the duplicates. Okay, there is a method called distinct that can do the job for you. Okay, I want to sort it in. Okay, you can also do the sorting as well with a simple method call. What else we want to do? We also want to, we have already done this, we have done this, we want to filter out the empty strings, right? We don't want that. So what you can basically do, there is a method called filter. Okay, so if you're passing me a string, what I'm going to do, I'm going to find its length. Only if it is greater than 0, I want to go further. Okay, and then what else we want to do? I want to do one more filter, and then I want to check whether if it is starting with A or B. Okay, if you pass me a string, I'm going to do check whether it starts with A, okay, or starts with B. Okay, I'm going to do this check. Once I do all this thing, I want to print each of them. So there is a method called for each, that whatever the value that is coming, you print all of them, right? So this looks much easier than the older way, right? So previously we have written a lot of code. Okay, we run a lot of for loops, and then we create a lot of list, set, all those collection. But here it's more readable, right? Again, if you want to do the parallel processing of all these things, okay, there is a method called parallel which you can call, which means if your machine have multiple cores, all these things gonna run in parallel, so that you save a lot of time. Okay, let's try to run and see what's the result we are getting now. So more importantly, all our intention is to create a more readable code, which is what we are doing here, right? So, right. So I think the test is still running and the results are out. Okay, we're getting the same results now, but this time we have written very simple code that anyone can understand. So what I'm basically doing, I'm converting whatever the element you have, I want to get that string out of it. Okay, now I have a stream of strings. Okay, I want to remove the duplicates, call the distinct method, sort them in alphabetical order, call the sorted method, and then I want to filter out only the strings that is having length is 0, length is greater than 0. I am doing that, and I also apply this particular conditions. At the end of the day, I want to print out all of these. That's what I'm doing. So this way we are writing more cleaner way of doing things instead of running a lot of for to writing a lot of conditions, right? Again, if there is a small change, okay, tomorrow if user comes, or you want to create a method that applies some other different logic instead of this, you can easily change here, but that is not possible with this. You have to again create one more method, and then you have to write your logic. But in case of Java 8 way, you can easily modify this. Okay, let's assume, okay, I introduce a new argument here. There is some functional interface called predicate that takes in string. Let's assume this is a predicate. Okay, so instead of this particular thing, okay, I can directly tell predicate. Okay, now here I can write whatever the logic I want. Suppose s dot starts with, I want only the starts with a, and instead of b I want s dot starts with c. Okay, I can write whatever the logic I want. Now I have the liberty to change the logic at the runtime. So suppose I want y and z, starting with y and z, I can also do that. So now the client has more control, and at the runtime I can change all these values, even this values or this values, whatever I want to change, I can change them at the runtime. That's the beauty about using functional programming, right? Good. So now I think you got a glimpse what the functional programming can provide for you. We will try to understand some basics, and then we can also see some other code. Maybe I can give you one more example where you can feel, okay, this is more better than older way. So let's take another example. Okay, so what I have so let me open a particular website, and then I'll try to tell the use case here. Okay, there is a drop down here. Okay, this drop down I want to select. I can select using visible text, I can select using index, or I can select using value. So there are multiple things that I can do. Okay, so if you go inside this is a select menu, and we have, if you want to select with value, you can use 1 to 10 and then red. You can also use select by visible text, and you also have the index as an option. In the conventional way, how we code this, okay, this is a conventional way of coding is, okay, I find the element, then what I'm doing, I have created one reusable method that takes in the element, and then it also takes it by what mode you want to do the selecting. Okay, whether you want to do it using text, index, or value. If it is equals to text, I will call select by visible method and pass the value. Okay, so this is the conventional way of writing a lot of if conditions. And you also notice when you are doing a index, okay, you also need to pass the index as a string, and then you need to convert into integer, because the select by index method accepts an integer. So we are writing a lot of if conditions, and this is very bad. So how we can optimize this code, particular piece of code? Okay, let's try to create one particular method. Maybe select drop down using Java 8 way. Okay, whatever, some name. Okay, so let's assume this takes in some consumer. Again, guys, for you the predicate, consumer, maybe little jargons for now. I will come back to the basics and explain what are all those things. But what I'm trying to do here is I'm trying to do try to make you get interested into a functional style. Okay, so be with me, we'll get into the basics, right? So let's assume I am passing a consumer like this. Okay, and let's also import it from java.util.function, and here I'll pass the web element. Okay, so let me pass the web element here. So now what I'm going to do is consumer.accept. Okay, I need a new select class, so new select, okay, element. Hey Amuthan, I don't understand what you have written here. Okay, let me do that. So if I have to select a magenta using text value, then what I can also do, I can call select drop down using Java 8. Now I need to pass a consumer. Okay, there's a lambda expression that you can pass here. Okay, so that doesn't accept, so it accepts a select class, right? So you pass E, okay, maybe element. What I can do, select by visible text. Okay, then magenta. That's it, guys. Now you pass the element here. Okay, I have the element, that is this. Now I don't have to write like this. I can write like this. So you are basically passing the behavior here. You are not passing the test data. We are passing the behavior. I want to select by using the visible text. We are passing the behaviors around and not the objects. Okay. So I'm waiting for one more second. And next time I want to select using value. Okay. Let's copy this same piece of code. And if I want to select using value, we are giving client more. So select by value, and what is the value? Value is 3. That's it. We have also done like this. Now I also want to select using the index, then copy this piece of code. Okay. And you can just still select by index, and then you can pass the index. Okay, let's say 6. Let's remove the older ways. Okay. Okay, so what I'm doing, I'm just selecting by index, and then I'm waiting for 1 second. Then I'm selecting by value, then I'm waiting for 1 second, then I'm selecting by index using 6. But if you notice, previously we are doing the conversion from string to integer, all those stuff. But here we are giving more control to the client. So what they can do, they can pass in the behaviors. Okay, I want to select by using visible text, and the color is magenta. The client is doing that, and my code is just one line, guys. See, it's how effective is, instead of writing a code like this, you can write a code like this. And now we are giving a lot of option for these guys. Okay, let's try to see whether the code is working. Okay, if the code is not working, then there is no point in optimizing the code, right? Let's try to check whether it is working. So if you notice, it was selecting all these values, and the test got also passed, right? So the same piece of code we have optimized, and this is just one line. And more importantly, this time we can choose the behaviors from the client itself. Okay, we don't have to go pass the test data, ask the this particular piece of method to do all the logic. Okay, if your requirement is select by visible text, call the select by visible text. As simple as that, guys. Okay, I hope now you got some interest towards learning Java 8. So now maybe we can learn about some basics, so that we can understand what is Lambda, what is anonymous inner classes, what is functional interfaces. So this particular piece of code, what you've written here, is called as Lambda. So how this works? Okay, what is this? Jargons, consumer, predicate. We have used something called as predicate here. What are all these things? Okay, it's time to learn them. Let's try to do that. Okay, let me create a new class called as runner. Okay, maybe I go a little fast, guys, because for time being, but I have explained all these things. Whatever I'm doing here, I have explained all these things in my YouTube channel. You can always have a reference there, but I'm trying to cover much faster way, so that we can save some time. Okay,
all right.
So let's assume Ajay, we are going to create some package. Let's create that particular package inside some demo package. Okay, for now. Okay, and the name of the interface, we can name it as printable. Okay, so printable is more meaningful name, guys, because your interfaces always needs to be in an objective. Okay, so let's create an interface called as printable, and let's assume it has a method called as public abstract void print. Okay, let's assume you have an abstract method called as print. So okay, if you want to provide the implementation for this particular method, what you have to do, we have to create a class. Okay, we have to create an implementing class. Let's name it as maybe console implementation. Okay, console impl. So basically it's going to provide some logic to print something on the console. Okay, so as simple as that. So this particular console impl is implementing your printable interface, right? So I have an abstract method that I have to provide an implementation now. So what I'm basically doing, for now I'm just printing on the console. Okay, this is the conventional way of doing things, right? Suppose if I have to call this from my main method, okay, let's assume I have a main method here, and I printable sorry, it's just printable. Okay, it's
Mhm.
printable. Maybe obj equal to new console impl, right?
Mhm.
And if I want to print it, I can use this and call the print method. So
Mhm.
basically, if I run this, it will print me whatever the thing that I have here, right?
Right.
So what we are basically doing here, Ajay, so we are having an interface and we want to provide the implementation for this particular interface. The only way that we know or we do prior to Java 1.7 is to create a implementation class and then write or override the logic and then provide our own logic. So that's the way, right? This is, let's assume this is our conventional way of doing things.
Mhm. Right.
This is the first way. Okay,
Mhm.
what is the second way? Okay, even
Mhm.
before Java 1.8, people use anonymous inner class. If the only purpose of this particular class is to provide the implementation for this particular method alone, and you have no other, you know, usage for this class anymore. Okay, just once you want to provide the implementation, after that you're not going to use this class anymore. In those cases, what you can also do, instead of creating an external class like this, you can create something called as anonymous inner class. So let's printable obj1 equal to new I printable. So, sorry, printable. Okay, so if it, okay, it has automatically filled all these things. Okay, let's remove them. Okay, guys, the reason why we cannot create an object for an interface, printable is an interface, right? We cannot create an object for an interface because it doesn't has an implementation, but in
Right.
class it has an implementation, right? Very simple. So
Mhm.
what I'm gonna do, if that is the only problem, if I, you know, what I can provide the implementation here itself. Okay, that's
Mhm.
what we can do. So if you press the control and space, it's gonna give you, you can provide the implementation here. You don't have to create it as an external class. So what I'm going to do, I'm going to provide the implementation. Hi, okay, maybe I am from anonymous inner class. Okay, so this is the
Mhm.
implementation. So if I want to call this object one dot print, okay, this is going to print this particular piece of thing. Okay, let's try to run it and see whether it is happening. Okay, these are
Mhm.
all very basics, right? So it is needed in order to understand what is Lambda. So this is printing me printing on the console, and I am from anonymous inner class. So this is the conventional way, and this is the anonymous inner class way. So why we call it as anonymous inner class? Again, guys, whenever you create a Java file, compiler converts them into .class file, right? Because
Mhm.
you know, you need to convert your, you know, human readable code into a machine readable code. The compiler does the job for us. So whenever it's doing, okay, let's go into this particular project folder. Maybe I'll open this in Explorer.
Mhm.
So let's go inside the target folders and let's see the generators test sources. Okay, sorry, generator test classes. Okay, I have something called as, so if you notice, there is runner.class and there is runner$1.class. What is happening here? Okay, for each of the classes that you have created, there will be equivalent.class file. If you notice, this is a runner class. Okay, so there is a runner.class. What is
Mhm.
runner$1.class? This
Mhm.
is an anonymous class, guys. Okay, we have a method. Okay, we have a method here that is in, you know, enclosed in another braces. That is a class, right? So
Mhm.
we have a method here. Okay, we have a method here that is enclosed in braces. That is a class. This class
Mhm.
is having a name, but whatever the class we have here is not having a name. So we can call it as anonymous. Okay,
Mhm.
this class is basically anonymous. It doesn't have a name. So compiler, creates a random name for it. Say runner$1.class,
Mhm.
and this class is present inside another class. So this is inner as well. So anonymous inner class, right? So we call it as inner class because it is present inside another class. We call it as anonymous because it doesn't have a name. Suppose if I create one more implementation, say for like this, okay, maybe test. Okay,
Mhm.
and then if I try to run the code, okay, you might see there are two anonymous inner classes, obj2 dot print. Okay,
Mhm.
so if we try to run the code now, okay, and if you check the dot class files, okay, let's go to the package explorer and see we have a runner.class file. Okay, we are now having two access inside the runner class. So you can also provide the implementation using anonymous inner class. But this code looks very noisy and very, it's having a lot of verbosity. There is a lot of chance that we can make a mistake here. Let's, from Java 1.8, Java compilers have become very smart. What they can do is they can do a lot of inferences. Okay, since my left hand side is printable, okay, I can obviously understand my right hand side is also be printable, right? And there is only one method here, and if you are creating a class and then implementing this interface, obviously we're going to provide the implementation for this particular method. So you don't have to mention it public void print. Okay, we also have public void print. Okay, so it can understand all this information, so you don't have to mention from here to here. Okay, so it is all, Java 8 compiler is very smart now. Okay, it can understand all these things. So what you can do, you can remove them. While removing them, okay, you are also removing braces in the 15th line. So you keep in mind, so I have removed a braces in the 15th line, so I'm also removing that. And I'm going to write a lambda way. So if you're if you want to sum two integers, what you do, you put a plus mathematical operator in between them, right? The same way I'm going to use a lambda expression. So you need to introduce a lambda operator, that is a hyphen and then the greater than symbol. So this is the lambda way of writing things. Okay, what you have done previously, it was a anonymous inner class implementation, but now this is just a lambda expression. Okay, so again guys, you might be knowing, if there is a if condition that has only one block, then you don't have to mention the brace. Same thing here, there is only one line of code, why you have to write the braces. Okay, let me remove that. So what else I have? I just have one piece of line, so I can directly write like this. So we have derived the lambda expression from anonymous inner class type. So instead of writing a noisy code like this, you can also write a simple code like this. Okay, this is basically, whenever you're writing a lambda expression, you can keep in mind you are writing a method implementation for an interface. Okay, so there are three things that we need to keep in mind, okay, when writing the lambda way. So we could write like this because there are three conditions that are satisfying. So one among them is your parameters to the method should match. Second condition, I'll explain what are these conditions. Okay, your return type of the method should match. And the last one is the interface needs to have only one abstract method, okay, and or unimplemented method. Okay, Amuthan, what is these things? Okay, guys, if you go to the printable interface, we have only one method. Okay, and then if you notice, the parameters to this method is null. So we are not passing any parameters to this method, that is matching here. So this is also matching here. Okay, suppose if I mention something here, okay, let's assume I'm passing in this, then it won't work, because the first condition is your parameters to the method and the lambda expression should be same. Okay, here in the printable interface, it's not accepting any parameters. In the lambda also, it is not accepting any parameters. Okay, what is the second condition? So if you notice, it is not returning anything. The return type is void here, and even in the runner class, if you notice, it's not returning anything. It's just printing out whatever the stuff that it thinks it printing that. It's not returning anything to the caller. So it is also matching. The return type is also matching. The interface needs to have only one abstract method, which means, okay, it has only one abstract method, right? Suppose let's increase this to 2. Okay. So increase this to 2, let's name it a scan, then it won't work out, because you cannot write a lambda expression. Okay, maybe in a older way, what you can do, you can basically implement the new method, and then you can provide the implementation here. In the anonymous inner type way also, maybe you can also implement the method, okay, and then you can provide the implementation, but that is not possible with lambda. Your compiler will get confused, okay, whether this guy is trying to provide the implementation for the scan method or the print method, because it doesn't know the name of the method. All it needs is the parameters to the method, and the return type of the method should match. There is two methods that is satisfying these things. So the compiler gets confused. Hey, you are trying to write a lambda expression, but I don't know for which method you are trying to provide the implementation. Okay, so you
Right.
cannot write a lambda for an interface that is having more than one abstract methods. Again, you can have default methods or static methods. Okay, that is not a big deal, but you cannot have more than one abstract method. So we call, if there is an interface that is accepting only one, that is having only one unimplemented method, then we can also call it as a functional interface. Okay, so we write a functional interface on top of an interface, so that if someone is trying to add one more thing here, okay, someone is trying to add new method here, it will throw error. Okay, it is telling either remove the functional interface or remove the scan method. Okay, you cannot have both. If there is a functional interface, it needs to have only one abstract method, so it'll stop people from adding more interfaces to that. Okay, now all the errors are gone. So let me do a quick recap. The older way, in the conventional way, we have to create a implementing class, and then we need to create an object for this and then call the method. In the anonymous inner way, we have to provide the implementation here itself. Okay, maybe I have removed the scan method, we don't need this anymore. So you need to provide the implementation here itself, but this is very noisy. So what we can do, we are removing all the things that the compiler can understand until here. And while removing, we are also removing one bracket here, so we'll also remove that. Okay, and we are telling we are going to write a lambda expression, so we are introducing a lambda operator. And if there is only one line of code, we don't have to mention the braces, so we can also remove that, and we can just write it in a single line. So that's how we derive a lambda expression from a anonymous inner class. But both of them are not equal. We may discuss it at some other point of time, but for now, just understand these three rules are very important. Okay, good. And if you also notice, if I try to run the test, it will all still work. Okay, let's try to, even though maybe I can write here as lambda. I am lambda 2, maybe something like this. Lambda test something. If I run this particular piece of code, it does not have any .class files. We'll see that. Okay, so there is an override method that we have added. We need to remove that. Okay, try to run it. So if you go to the particular class folder, if you notice, we don't have runner $1, runner $2 anymore, because these are all just a method implementation and they are not class. They are just behaviors. What is the behavior? It doesn't accept anything but prints something into the console. So this is a behavior itself. We can have behaviors stored to a reference variable, and we can pass it around whenever we want. Okay,
right.
So this is the way how we can write lambda. Good.
All right.
But what is the problem? Okay, suppose Ajay, we want to use this knowledge, and then we want to use it in our code. So we find this very interesting. So what is the problem? So, okay, suppose I want to have a print method that takes in a string argument now. Okay, okay, let's remove the console implementation. We are not bothered about the older way anymore, so let's try to delete it. Okay, we'll only focus on okay, we will also remove this. Okay, we can only focus on the lambda expression now. So we have changed the method parameters to that accepts a string. So here it is not matching, so you need to mention string A, then only it will work. So it has to match. Okay, so this is now accepting a parameter, string parameter. So whenever you're calling the print method, you have to pass it. Okay, let's say Amuthan. Okay, so now if I try to run the test, okay, let's remove the unused imports and try to run the test. It will print, I am from lambda. Maybe you can also provide a different implementation. Maybe whatever the string that I'm passing, I want to print it, maybe to uppercase. Okay, something like that. So if you can also provide an implementation like this. Okay, so it is printing me in the uppercase.
Right.
So hey Amuthan, you are telling Java can understand a lot of things. Why it cannot understand that we are passing a string. Though the method is having a signature that is clearly telling it is an input argument as a string. Yeah, it can also understand that. So you don't have to mention this. Okay. You
All
don't
right.
also have to mention this. Okay. It can also understand that, right? And if it is just one parameter, this bracket is also not needed. Okay. Again, it is just a variable, right? So you can also have this as a name a string, and then it can be anything. It can be string, it can be a, it can be c, whatever. It's just a variable name, right, to a method. So it can be anything. Now, for simplicity, people represent a string with s, so we will use s for strings. Okay, good. So now there is again another problem. I want to have one more method that accepts an integer. Okay, what I have to do, I cannot add it here because I cannot have another abstract method here. So what I have to do, I have to create one more interface. Let's name it as integer, printable, something like that. Okay, I need to create one more interface, and then I need to create one more abstract method. Let's say public abstract um, void print that takes in integer a. Okay, I need to provide. Sorry guys, this is an interface. Okay, so now I have created a new one. So if I have to use this in a code, how we can use it? So this is integer printable. Okay, integer printable, maybe obj2 equal to, it accepts a integer, right? So whatever the thing that I'm going to write, I'm going to print that particular thing. Okay, that's it. So this is the default implementation. So now I have to use this in a code, obj2 dot print. Now it's accepting integer. Maybe I can pass 5. Okay, let's try to run the test and see what's happening. Okay, so it is printing me 5. That's also fine. So, but it is not possible. Suppose tomorrow, I want to have one more print method that accepts an employee class, that accepts an array list, that accepts an hash set, that accepts an hash map. So I cannot continuously create a lot of interfaces. That is very noisy, right? I cannot do that. So what you can always do is basically you can have this printable itself optimize using generics. Okay, let's say t, and then let's change this to t. Maybe I can also change this to t. So what is this, Amuthan? I don't understand. Okay, guys, if you notice, we normally use a lot of code using array list, right? So let's remove all of them. Okay, remove all of these, and how we will write a array list. So we'll tell a list string. Okay, and then we'll tell list equal to new array list. We'll do that. Okay, this is the oldest. We are using this for a very long time. So this is generics, guys. We are telling that we're going to pass string. Okay, so if you go to the list interface also, they are using e, but you can also use t. That doesn't matter. But basically, whatever the thing that you're going to pass, that will be used here. Okay, wherever they are using e, they can use it. So let's take an example from here itself. So if you pass a t, suppose t is string. Okay, then this method will also accept string as the parameter. Okay, so dynamically user can choose it. Okay, let's go to the runner class, and now while creating a printable object, okay, if you notice, we need to pass the generic type here. Okay, if I want to use a string, okay, I can use like this. Maybe obj equal to, okay, whatever the s that you pass. Okay, I want to do a s dot to uppercase. Okay, next time I want to use the same interface, but this time I want to pass an integer. Okay, I want to store integer type. So we are going to utilize the same interface, for passing different things. Okay, so s out, maybe I plus 2, something like this. So if you guys notice, we are using the same interface instead of using multiple interface. That's because we have introduced generics here. Okay, that's the pretty much good use case for having generics. Okay, now if we want to do obj dot print, this obj is accepting string. So if you notice string t, because it knows you are going to accept a string, okay, from the left hand side. So pass a string, and obj1 dot print is accepting an integer because you have mentioned in the left hand side it's going to accept an integer. Okay, so if I try to run it, Okay, it's gonna print me Amuthan in uppercase and 6 plus 2 8 in the console. Now just by using single interface you could do any of these. Suppose tomorrow you want to pass in a employee reference here, employee class or your custom classes, you can also do that. That's pretty cool. But even then I have to write a lot of things, because tomorrow let's say I want to accept something and then I want to return a string. Okay, this is not possible. I have to create an interface. I need to introduce generics, and then I need to, accommodate this. But this is not possible, right? There are a lot of combination. It can accept 2 parameters. It can accept 3 parameters, or it can return something else. Okay, there is a lot of combination that we cannot create a lot of functional interfaces for that purpose. So Java themselves have created some list of interfaces. Okay, maybe if we can go to Google and then Java 8 interfaces, and maybe I'll go to the just a minute guys, maybe Java interfaces, Java docs. Okay, not this one. I'm just trying to show you guys what are all the in functional interface. Maybe functional interfaces would be the better word. So if you notice, they have created a lot of functional interfaces. For example, we have a printable interface that accepts something and doesn't return anything, right? So there is a method that takes in 1 parameters and doesn't return anything. Then there is something similar here, consumer, that takes in T, see, represent an operation that accepts a single input parameters and return no results. Hey, if you have a use case like this, you don't have to create your custom interface. You can directly use this guy and then use it in your code. Okay. So they have also create a lot of other functional interfaces for our use cases. Among them, 4 of them are pretty important. So one of them is consumer, and second one is supplier, and then third one is predicate. These are all just the name guys. Okay, fourth one is function. Okay, so these are the 4 functional interfaces that are pretty common and widely used. Okay, what is a consumer interface? Okay, see the name itself. So it is going to consume something. Okay, but it's not going to return you anything. So the method signature can be something like this. It takes in T. Okay, and then can be void. It's just a void method. The name can be anything. Okay, so it's a void method, but it takes some generic type. Okay, whatever the generic you mentioned, it's gonna take that. Okay, there is another interface that is going to have only one method. Okay, that going to supply something. Okay, so the return type is T, but it's not going to accept any input parameters. So it's just a supplier. It will just supply you, but it does not needs anything. Okay, what is the next one? We have a predicate. See, predicate name itself is telling it's going to predict something, whether it is true or false. So the return type is Boolean, and it's going to accept just only one parameter. Okay, and then there is another interface called as function that names itself telling it's going to do some operation. So it's going to accept something and then return something. Maybe it's going to return U type and it's going to accept P type. So it can accept something and return something. Okay, so these are the 4 interfaces and 4 methods that are widely used. Okay, let's dig deep into these interfaces and see what they are doing. Okay, let's go to their implementations. So if you notice, I have consumer. So this is an interface, consumer interface. See, that takes in generics as T, and it has a method called accept. And then whatever the tree, if you're passing T as string, this method is going to accept string. This is having only one abstract method. It is a functional interface. It can also have other default methods, but I'm not going to cover the default methods for now. But just understand this particular method. See, the name itself is very, very meaningful. Consumer, it's going to consume something. The method name is accept. It is going to accept some parameters. Okay, some very easy names, right? Good. So it is same as this. This is same as our printable interface. So printable, the name is different, consumer printable. This is print here, this is accept, but the method signatures, this are all same. So if you, whatever the code we have written so far, instead of using printable, what I can do, I can use consumer. Okay, consumer. So I can import this guy from java.util.function. Now the same code will work. Okay. So what are you doing? Obj dot, okay, accept is the method. So the method name is changing, but the implementation is same. So it's going to accept a string. So then obj1 dot accept is a method, and what it accepts, it accepts an integer, let's say 9. So yeah, the same code. You don't have to create an interface, guys. If you have a use case like this, please utilize the functional interfaces that are available already in the Java classes. Okay, you don't have to create on your own. So that's what the Java developers are telling us. Okay, so it will still work the same way. We are not making any changes. Okay, good. So now we have covered about the consumer interface. Very simple. It's gonna accept something, and it's not going to return anything. Whatever the operation you want to do, you do it. You don't care. Okay, that's the consumer interface. Suppose you can also open a second one, that is supplier. Okay, supplier. Okay, I can open this. This is a very simple interface. Whatever the thing, just call this method get. It does not accept any input parameters, but it's going to return you something, whatever the type that you are mentioning. Okay, so it's very simple, right? So let's try to use it in our code. Okay, let's remove this. We don't need this anymore. So supplier is an interface. It is accepting a generics. Let's say I want to return string. Okay, if someone is calling me, say the variable name is say hello. It does, the method signature doesn't accept anything, but I'm going to return something that is hello. That's it. Okay, so if I have to use this in our code, let me do an s out, say hello dot call the get method. That's it. So if you run this, it is going to print you hello. Okay, so this method doesn't accept any parameter, but returns you the generic type. Okay, it can be anything. Okay, it can be a random value or it can be a constant value, that doesn't matter, but it's going to return that. Okay, it can also accept string. You can also explore this using an integer type, but for time being I'm skipping that, and we'll go to the third one. Third one is predicate, right? So predicate from the class files, predicate. Okay, from the java.util.function. So as I already told, the name itself is clear. Okay, it's going to predict whether it is true or false. Okay, you pass some string, I'm going to return you true or false. That's it. You do whatever the operation you want, whether the string is having length greater than 0, whether it is starting with a, whether the integer is divisible by 2, whatever the operation you do, but at the end of the day, return me this method going to return you true or false. See the method name also, it is going to test something, so they have named it as test method. They have named the interface as predicate because it's going to predict whether it is true or false. This is an easy way to remember all these names and stuff. We can also use this in our code. Maybe predicate, okay, string, which means you're going to accept a string and then I'm going to return true or false. Maybe is empty string. Empty string. We can write the logic. So you pass a string here, okay, and I'm going to do a length. If the length is equal to 0, then it is an empty string. Correct? So that's it. So that's what we have even used in our first Amazon demo test. So we are passing a predicate here. Okay, this predicate is basically we are checking whether it is starting with A and also starting with C. So this is the predicate, right? It's going to predict whether it's written true or false. Okay, good. And let's go to the runner class. If you want to do this is empty string, there is a method called test. Okay, pass the string. Okay, now I want to pass the string like this. So what it'll do, it'll check whether the string length is equal to 0 and it's going to print me. Okay, I didn't call the s out statement. So let me call this s out statement and then print the value. So it's going to return true or false. In this case, it is true. If I just change this to some values, it's gonna return me a false.
All right.
Okay. Yeah. So as simple as that, right? So, and then the last one, Ajay, is your function interface. So this is an interface that's very cool. It's going to accept something and it's going to return something. If you notice, it is accepting t comma r, which means whatever the first parameter, first generic type you are giving is your method parameter. What is the second thing that you are giving is your return type. Okay, so this is generics way of writing things. Okay, let's try to use it in our code so that we can understand what it is. Okay, I'm going to use function that takes in t comma r. It is clearly telling you pass me the generic. What is the input parameter type and what is the return type of that method? Maybe the input parameter is string and the output parameter is integer. Okay, what I'm going to do, a length, it's a length lambda. Okay, if you pass me a string, I'm going to return you s dot length. That's it, guys. Okay, so it's very cool, right? So you take an input parameter that is string, and but you are returning the integer. Okay, that's it. So if I want to print it, s out dot length dot, there is a method called apply, and you pass me the string. So I'm passing the string. Now if I run it, it's gonna print me 7. Okay, because this is a lambda that takes in a string and then do some operation and then convert into a string. Again, it can also convert me, give me this, something like this, to lowercase or whatever. Okay, it doesn't mean that it has to always return a new different type. Okay, it's not the case. Okay, it can also return, it can take a string, it can also return a string. This time I'm doing 2 lowercase, can also do 2 uppercase. Okay, whatever you feel it's more relevant, you can also do it. It's not just always it has to convert into a different type. Okay, so it has also done the task for me. Again, if you notice one cool thing, my ID is suggesting something. Okay, what is telling? Hey, you are getting some input and you are directly passing to another method. Okay, you are not doing anything. Then this is very noisy, or it is having little verbosity. You can optimize this using method reference. Okay, method reference is again a concept where if your lambda is accepting some parameters and directly pass it to another method, then you don't have to write it very long. Then here I can just tell I'm gonna do 2 uppercase or 2 lowercase, whatever. So now you use the double colon operator that indicates we are using a method reference here. So whatever the input that you are getting, I'm going to pass it to a 2 uppercase method inside the string class. Okay, so this is as easy as you get. Okay, I hope you can follow me till now, right? Ajay?
Yeah, I can.
Yeah, good. So good. So I think if anyone is having doubt, they may ask it in the premiere. That's okay. But now we have got enough glimpse of all the 4 functional interfaces, right? So we have where I have written that. Okay, these are all the 4 things. Okay, consumer that accepts something but doesn't return anything. Supplier that returns something but doesn't accept anything. Predicate, it accepts something and returns a true or false. And then function that takes in something and returns something. Okay, so this is a simple interface, and this is what we have been using in this particular piece of code. Okay, Amuthan, I didn't understand. Okay, let's go again and dig deep. Okay, the map method here, if you notice, it's accept something. As I told, this is accepting a function here. So what is a function interface? It has a method that accepts something and returns something. So in our case, it is accepting a web element and returning you a get text from it. So that's what we are doing. It's you call get text. Okay, we are using method reference. You can also use whatever the you are passing. I'm gonna get the text out of it. Okay, you can also do this. You can also write like this. Okay, this is a lambda, right? So it takes in a web element. You have stream of web elements. You take a web element, you get the text out of it. That's it. So we are converting from one to another. So this is little verbose. What we are doing is we are getting the input parameter and directly passing to this method. So we can also optimize this using writing the lambda way of the method reference instead of using a lambda. Okay, that's what we are doing. So if you notice, this filter method is basically accepting a predicate. So if you write like this, it's gonna tell it's taking a predicate. So it's a predicate that accepts string as the input type. You do whatever you want, but return me a true or false. Okay.
Mhm.
Suppose in this case, what I'm doing is I'm taking in a string, I'm checking whether the length is greater than 0.
Mhm.
Okay. You can do whatever the operation you want. There is
Mhm.
one more predicate. Okay. I'm also applying one more predicate, and that is this. Okay. Whether I'm checking whether it is starting with A and starting with C. But at the end of the day, it is returning me a true or false. So this is another predicate. Again, if you
Mhm.
notice, this is a for each loop, for each, right? So
Mhm.
whatever the strings is coming one by one, it's basically your consumer interface. Okay. So
Mhm.
let's remove this, and then see, if you notice, for each is accepting a consumer of string type. Okay.
Mhm.
So consumer is, again, you have to go to the basics. Consumer has a method called accept that takes in a string parameters and doesn't do anything. Okay. Yes, it is also doing the same thing. So
Right.
I'm going to accept some string, whatever the thing that is coming, I'm going to do an s out and then print it on the console. I'm not going to do anything else.
Mhm.
Okay. Now this code will work. This is a Lambda code. But if you notice, whatever the input parameter we are getting, we are not doing any change. We are directly passing to the method called as println, right? Println is a method we are passing to that. So we can use method reference and then optimize this code by system dot out dot colon println. That's it. So this is just a method reference, guys. You can also write yes Lambda operator system dot out dot println, and then yes, you can also do the Lambda way as well. Okay. So I hope this makes some sense, and we also understood how we can use this in our code. We will see more examples so that you guys can correlate what I'm speaking here.
Mhm.
Good. So let me go back and then try to cover some more topics. Again, I
Mhm.
think Vijay, Ajay, we are getting past the time. Can I extend a little bit?
Yeah, yeah, no worries. Please go ahead.
Yeah. Okay. Maybe we can cut down the design patterns, and then we can only cover the Java 8 way. Maybe some other day we can cover that. But if time permits, we can also cover one or two design patterns. Okay.
All right. All right.
Okay. Okay. Now let's quickly, for time being, let's get little faster, and maybe I'll take uh, some interesting use cases. Maybe this one. This is really cool. Okay. So this is an I have a list of integers, right? So what I want to do, I want to perform sum of all these numbers. So what we will do, we will create a method called sum, and then we accept the list, and then what we are doing, we are initializing a sum equal to 0. We are iterating using a for loop. We are at the end of the for loop, we are calling the sum, printing the sum variable, right? This is what we are doing. This is a normal way of doing things, right?
Mhm.
And if tomorrow your manager comes to you and tells, hey Amuthan, don't want just the sum. If I pass you a list of integers, you also need to I just want to find the sum of all the odd numbers in this particular piece of list. Okay.
Mhm.
Okay, that's really cool. What I will do, I'll copy paste the same code. I'll introduce new if conditions in between. So whatever the uh, number that I get, I'm checking whether it is divisible by 2. Only if it is not divisible by 2, which means it is an odd number, then what
Mhm.
I'm doing, I'm just calculating the sum. Basically,
Mhm.
I'm introducing a if condition.
Mhm.
Tomorrow he is coming and telling, hey Amuthan, I want to find the sum of all the even numbers. So
Mhm.
hey, that is also very easy for me. Okay, I can do like this, sum of even numbers. So
Mhm.
here, instead of the not, I can remove this and then put equal to 0. All the tasks are done. Then another day, manager comes to me and tells sum of numbers that is divisible by 3. Okay, then I'll again copy this, again paste this, sum of numbers uh, divisible by 3.
Mhm.
Okay. Okay, then I'll just change this to 3. Hey,
Mhm.
this looks very easy. Your manager is a good guy, but I am a bad guy, so I'm not writing a clean way of doing things, right? So you
Mhm.
are repeating the same lines of code again and again, but you cannot try, tomorrow there is one more requirement. You cannot keep on adding things, right? This is
Mhm.
very bad, right?
Mhm.
We call it as a crime in software testing. So if you code like this, maybe you need to think about an effective way of doing stuff. Let's try to do that. So let's have some method, some using Java 8 way. Okay. So that accepts the numbers, right? So first let's create a very simple method. Okay. So what it does, I want to actually print the sum of all the numbers. Okay, let's do it. A numbers start. Okay, you have a stream. I introduce a stream. What I want to do, I want to map. So I have now I can pass an integer. So basically, there is something called as map to int, which I can use to convert all the integer type. So integer type. Okay, integer type is different from your int type. Integer is a wrapper class, int is a primitive type. So what I'm basically doing, I'm converting all these integer to int value, and then I want to find the sum of it. Okay, now I want to print it out. So I'm just basically telling I want to print all these things. Okay, so if I try to run this, okay, this will again work. Let's see whether it is working. It should print maybe 55. Yeah, 55 is the sum. It is working absolutely fine, no issues. But if you notice, we are not running for loop, if conditions, not all those things. Hey, Amuthan, how do you accommodate the new requirements? Okay, maybe I introduce, let's assume this is accepting a predicate of integer and predicate. Okay, and then I introduce a new filter that filter out with this particular predicate. Okay, let's import this particular class from java.util.function. Now I want to find the sum of odd numbers. Okay, then whatever the number that you get, okay, I'm gonna do percentage by 2, and then I'm gonna check whether it is not equal to 0. Okay. Okay, Amuthan, how will you find the sum of all the numbers? Okay, sum of all the numbers is very easy. So whatever the I am getting, that doesn't matter. I'm going to return true for that, because this is a predicate, right? Predicate takes in this predicate is taking an integer. So we need to take an integer and provide a true or false. So this is for sum of odd numbers. This is for sum of all the numbers. Sum of all numbers. Okay. And if you want even number, it's very easy. So I can copy this. Okay, I'm not changing my code anywhere. Okay, I'm changing only the client requirement. If they have different requirement, you're just satisfying them. Okay, so if tomorrow they want divisible by 3, okay, whatever the thing, that doesn't matter. I will also give you divisible by 3. So now if I try to run the test, it is still throwing some error because I need to call this for here. Okay, so because this filter is a predicate of integer, so I'm actually converting that to primitive type. So I have to apply this before. I will first filter out all this in numbers, then I will convert them to primitive type, then I'll find the sum. Okay, so if you notice here also we are getting all the answers, and importantly we are not creating a lot of code like this. Okay, just one simple piece of code, and then we are just passing the behavior around, a predicate behavior around, and then trying to accommodate our needs. This is very cool, right? We are not writing a lot of code, and if there is something
awesome.
that needs to be improved, right?
Yeah,
you can see the changes, right? How this can bring a lot of changes for you. Whatever I teach is just basically 1 hour of concepts, but people are not ready to learn this, and then they are very comfortable writing the older way. Only when they see a use case like this, they get inclined to start to write like this. Okay, maybe I'll show more use cases so that you get, I'll at least try to convert one people from the writing the imperative style to the functional programming, so that I can do enough justice for your time and my time as well. Okay, let's take another example here. Yeah, another example. So we normally get a lot of JavaScript pop-ups in our code. Okay, I want to write a code that sometimes the pop-up will come, sometimes it will not come. We don't know when it will come, when it will not come. So I need to write a code. If the pop-up is present, I need to click on it, click on accept button. If the pop-up is not present, I want to ignore it. I don't want to do anything. Okay, so how will you write the code for this? Okay, how normally people will write? They'll write a type catch. Okay, if this is present, I want to switch to the alert and then accept it. Okay, if it is not present, you don't do anything. It will throw a null pointer exception. You catch the exception. You don't do anything. We're eating the thrown exception. We are not doing something. But when you're writing a lot of try catch blocks, you are spoiling the readability. Okay, this is not a more effective way of doing things. Okay, so what people can also write, there is an accepted conditions. There is a class called expected conditions, and there is a method called alert is present, and they are checking whether it is present. If it is present, it won't be null. If it is not present, it will throw a null pointer exception. So what we are avoiding, so I'm checking whether it is present. Okay, if it is not equal to null, which means if it is present, I click on it. Otherwise, we are not doing anything. But there is a new concept in Java 8 called as optional, where we can leverage this code and then try to write more effectively. Okay, if you want to see what I can do, I am doing here. I'm just opening a Chrome browser, and then I'm creating a JavaScript alert myself. Okay, I'm using a JavaScript executor and creating alert. I love testing Mini Bytes. Okay, so first way I'm using try catch block and then handling it, and the second way I'm using this particular expected conditions class and then doing it. Okay, this is okay, but we can also optimize this. Okay, this piece of code, I don't write a lot of try catch because it spoils my readability. There is no intention for me to write a try catch block here. Okay, so I'm not interested. This is okay-ish kind of code. Still we are writing if conditions. We can also avoid that. So how we can do this then? Okay, maybe I'll create something accept alert using Java 8 way. Okay, maybe the method name should be much better, but for now I'm not worrying about that for much. Let's create a method, and there is a class called as optional. Okay, there is a class called as optional, and there is a method called as off nullable. Okay, that takes in a generic t. So what I'm going to do, off nullable, I want to check whether something is nullable. Okay, basically this not equal to null, this check is done here. Okay, if you notice this off nullable method, that is actually doing whether the value is equal to null. If it is null, return an empty. Don't throw the null pointer exception. Instead, pass call the empty method. If it is not null, you pass the value itself. So basically, whatever the code that we are writing, this if condition code, they have already written for us. So we are trying to leverage that, and we are going to use it in our code. So basically, I'm going to use expected conditions. Alert is present. Okay, apply that takes in a WebDriver. There is a method called apply that takes in a driver. And what I'm going to do, if you press a dot or it, okay, see, there is if present method. If present method accepts a consumer of alert type. Okay, so consumer means it accepts something, but it doesn't return anything. Okay, only if it is present, it's gonna do something. Okay, so whatever the alert that you have, okay, I'm gonna call. If it is present, then I'm gonna call accept method. Okay, that's it, guys. So you write one line of code. You don't have to write a lot of if null, all those checks. You don't have to do all these things. If it is present, you click on it. Otherwise, don't click on it. Okay, maybe we'll remove these things. Okay, I'll just use this and then try to run and check whether it is handling the pop-up or not. So this if present method is accepting a consumer interface. That's why we need to know how to use the consumer. So now there is a pop-up, it is getting accepted. Now, if I don't, create this pop-up, okay, it should basically ignore it. Okay, it should not do anything. Right? There is no pop-up, there should be no failure. It should not throw null pointer and all. So let's see. So there is nothing here, no pop-up came. So it is completely ignored, and we have achieved the same thing using optional class. So optional is something, if you are facing a lot of null pointer issues, all those stuff, okay, maybe you can try to leverage the optional class and then try to avoid all those null pointer exception. So this is another use case that I can think about. And there is also a lot of things that we can do with basically Java 8. So maybe I can show one more example that may be relevant to you. So let's assume I have maybe instead of showing this, maybe I can show something more easy and then more effective. Okay, so let's take, I'm logging into, I'm just loading the Amazon.in website. Maybe I load that. Okay, let's take some time. Okay, I have an Amazon.in website, And if you notice, I want to click on this hamburger menu, and then all these menu here are basically having same or almost same XPath. So if I try to write an XPath for this, okay, I can basically write using // div text equal to this. So clicking on a div tag is not that good. So I'm just trying to find the parent tag of A. Okay, so I'm basically trying to click on the A tag that is having text value as mobiles, computers. Suppose if I change this mobiles and computers to this particular value, then it will find another element. Okay, so all these things are almost having same XPaths. Okay, if I just copy this, and then instead of mobiles computers, if I pass this, it will find the another element. So you don't have to create 100 elements here. Basically using a single string locator, you can find all these web elements. Okay, good. So now what I'm first doing, I am first clicking on the hamburger menu. If we are using string as a locator, so okay, what I have done, so this is the XPath that we have found there, right? Div text equal to mobile computers parent A. So I'm just trying to replace this with the wildcard %s. At the runtime, I will replace this with some values. Okay, so I'm using string.format method. So this particular XPath will be converted to this particular XPath after this particular operation. Very simple, guys. Okay, I'm just at the runtime, I'm converting this %s. I'm replacing that %s with this particular value. That's it. I'm doing. Okay. Now I have created a method. Okay, if there can be, I can use if I use a string, it can be of name, it can be of ID, it can be of XPath, it can be of CSS selector. So I have to create some reusable method like this. Okay, so what I'm basically doing, I'm writing left of if condition. If the so if you have to use this, I need to tell, hey, I want to use XPath and this is the XPath. Okay, so if the locator is basically ID, I want to find the element by ID and click it. If the locator is XPath, I want to find the element by XPath and I want to click it. So it's very, very verbose, right? And there is a lot of chance that we can make a mistake here. So how can we improve this particular piece of code? That's a question. Okay, don't write a lot of if conditions, guys. If there is more locator type, you need to write a lot of if condition. If there is a change, very hard to make. So in those cases, what you can do, I can basically create some factory classes like this. Again, factory may not be a unique full name, but for now, just understand you have a locator factory. Okay, our intention is to take in a string type and then return a byte type so that they can use effective way of writing the things. Okay, let's be, just be with me for some time, you can understand what I'm doing. So let's create some static final function. Is an interface that takes in an input parameter and returns something. So it takes string. I want that to take a string and return a byte. Okay, so let's assume first one is ID. So I am accepting some string and I'm gonna do by.id string. Okay, let's try to copy paste this, and then for name I want to add name, and then for XPath I want to do XPath. And guys, this is a function, is an interface. We are writing lambda expression. Okay, so if it is a name, I want to call by.name and then string. If it is XPath, I want to call XPath. And using the static block, I'm going to load all these things into the map. Okay, it's a key value pair, right? I'm going to store into that. So map dot push. Maybe if someone is telling ID, okay, if someone is telling ID, I'm going to return them by dot ID. Okay, so just be with me, guys. You're going to easily understand this. It's not a big deal. If someone is telling XPath, I'm gonna return them XPath. Okay, simple as that. I'll create one method. Okay, maybe a public static by get by locator, something like this, that takes in a string. Okay, or maybe string locator. So I'm going to return them map dot get locator. Apply, then I'm going to pass the string, whatever. I'll explain this, just be with me. String, or maybe it can be value. Okay, I don't understand this. Yes, I can hear your voices, but basically, guys, I'm going to do a very simple thing. Okay, here we are right. All our intention is to find the byte type, for the corresponding locator. Okay, so if someone is telling XPath and then some value, if they are passing me XPath and some value, I need to basically find the byte type of it, so that you can directly use this method and then click on it. You don't have to write a lot of if conditions like this. Okay, instead, okay, let me create that particular class. So public void, let's name it as click using Java 8. Okay, it also accepts all these things. Okay, now instead of writing a code like this, what I'm going to do, I'm going to tell locator factory, okay, dot get by locator. Okay, I'm going to call this method and then pass the locator and the value that I'm having here. Okay, now all these logics are wrapped inside this. Now I go here, I see, okay, you are passing me locator and value. Okay, what I do, map dot get key, I'm passing the key. In this particular hash map, the key is ID. If I pass ID, it will bring me the ID. So this is the ID. What is this? It is a reference variable, right? So basically it's going to find the element using the ID locator type, and then it's going to return me a byte. Okay. If I pass a name, it's going to find the element using name property, and then it's going to bring me the by locator. If you pass the XPath, then it's going to find the element using the XPath property and going to return the byte. Again, if you notice, this is again a lot of code, right? You can replace this using method reference. So I'm doing that. So whatever the input parameter that I'm receiving, I'm just going to pass it to the name method. So I can basically use class name : method name. So this is the way that you can do. You can also write like this. Again, the only need for creating these variables is to explain you guys. If you can understand, you can directly create like this. You don't need those reference variables. Okay, you can write like this, and then you can remove all these things. We don't need them anymore. Now the code is very clean, and if you want to click it, you can easily do that. So whatever the locator that you are passing, I'm going to convert it to maybe to uppercase. For now we can use a enum, but for now I'm just converting to uppercase and then giving here. This guy will go and search. If it is XPath, it is going to find the byte type of it, and then it's going to return me a byte type. So what in my code I'm going to do, I'm introducing a new local variable. Let's name it as by. Okay, and there is already a click method that is taking by parameter. So I'm just calling the click method and passing the driver and the by. That's it, guys. So instead of writing a big noisy code like this, okay, we're going to write just 2 lines of code. Again, if you can understand, you can, instead of creating this local variable, you can also directly pass this here itself. Okay, now let's try to check and then see whether it is working using the click using Java 8. Okay, that's it. It has to click on the hamburger menu, and then it has to click on the mobile computers link. Okay, this is really handy if you have to use a dynamic strings in your Selenium automation framework or the mobile automation frameworks. Okay, let's try to run it. So it has also clicked on it, and the one of my tests got passed. I think maybe all the tests got passed. I will stop it here. Maybe we are already past 1.5 hours, so I'll stop it here. Maybe you can refer my design pattern playlist. The same way how we are optimizing our code using a Java 8, we can also optimize the same piece of code using design patterns. Okay, please do refer my Java 8 playlist and design pattern playlist in my YouTube so that you can understand. And if at least one of you started to think about functional programming and start to use Lambda expression in your code, I think my time and Ajay's times will be, it will be justified. Thank you, Ajay. You are being a very generous host and very patient me in hearing all these my talks. Thank you so much, and that's all from my side, Ajay.
All right. So, Amuthan, thanks for sharing this much knowledge which you are carried with you so far, and thanks for telling us and showing us a way to move from a traditional way and try something new by using Java 8.
Yeah.
Anything else you want to share before we wrap up this session, Amuthan?
Nothing, Ajay. As I told, if at least one among the people who is watching this particular session can try to change their way of writing code and then start to write more effective and cleaner code using Java 8 or the functional programming, I'll be really happy. I request them at least watch. There are there are a lot of things that exist that we are still not adapted in test automation. We have to do that. At the end of the day, we need to write a very quality code like our developers. We cannot still write the old fashioned way, and then we cannot get a lot of scoldings from our developers. Okay, so we have to improve our coding style. I think this may be a first step for them. So I'm hopeful at least one among them will learn it.
All right, that's true. Amuthan, if anyone wants to reach out to you to understand these things in more detail, so what is the way to reach out to you?
Anyway, I have a testing Mini Bytes. This is my YouTube channel. Okay, you can check there, and I have my testing Mini Bytes Telegram channel. You can, there are a lot of peoples. We have some useful discussion happening there. You can join the Telegram group. Ask the doubts directly to me. If you have any queries, you can directly reach out to me there, or you can also write to me at testingminibytes@gmail.com. So you can write your queries to this. I'll try to answer them as much as possible. But I would suggest you to join the Telegram groups that is completely free, and then you can directly ask all your questions there. I do post a lot of good stuff, lot of questions there. I'll take the answers from them. I'll try to pour in a lot of bad codes, try to optimize them using a lot of designing techniques like design patterns, Java 8 and other topics. So testing Mini Bytes Telegram is the way, guys. Okay.
All right.
Maybe I can give you the link so that you can attach in the description, Ajay, so that they can also be part of it.
All right, Amuthan. Okay, so thanks, Amuthan, for joining us over STET and sharing your knowledge based on your experience in your tenure in the IT industry so far. I hope our audience would have learned a lot of things from this session, and we would be expecting more such sessions from you in upcoming days as well. We wish you all the best for upcoming projects on which you're working on, and thanks for being part of our STET journey.
Thank you, Ajay. It was pleasure of mine to be part of this particular STET series where you have hosted a lot of beautiful experts across the globe. I'm really glad I could be part of it. Thank you again. You are such a wonderful host. Thank you guys for listening to us. You all have a very good day. Bye.
Thank you, Amuthan.
Thank you.